So in this video, we are going to talk about LLM models, or the brain behind your voice AI. So before we get into that, we are going to look into multiple layers behind a voice AI structure and how LLM fit into that layer. So let me walk you through the multiple layers that are involved in making a successful voice AI call. So let's get started. So when an AI agent is receiving a call, the input that an AI agent receives is the speech from that caller. So let's call this block STT, and this means that speech to text. So this is the first component of a voice AI, which is speech to text. So the input here would be the speech that is coming from a phone call, right? So someone is making a call from, let's say, from LC phone, or maybe they're calling from a Twilio infrastructure. So these are the places where the input is coming in. And the input that this AI agent is going to receive is, of course, a voice. And this voice or the speech is then converted into a text using an STT or speech to text tool. So for that, we use something called a transcriber. And there are so many transcribers in the market. And Deepgram is one of the popular ones. And you can also find something called Whisper. So there are so many similar tools that does the transcription or the speech to text conversion. So this is the first step of a voice call. The voice is coming in, and then that is getting converted into a text or into words. So once the transcriber converts the speech into a text, the output of this STT would be text or words. This output is then fed into the next block, which is our LLM block. So you have another block here. So this block, the LLM block, is the brain of any voice AI agent. This is where all the processing would happen. This is where all the prompt would go in. And whatever text that is coming in from the speech is actually converted into or processed through the LLM in this block. And inside the LLM, you will find multiple orchestration layers, or for a rather simpler word, I would call it functions. So these functions are used to find out the endpoints, to find out the turn taking, to find out emotions, backchanneling, and so on. Depending on the functionalities offered by the software, you will find multiple functions inside this LLM module itself. And that's where you have to pick the right brain or the model for all of these functions and more to run. Because LLM will also have your prompt, maybe the system prompt or the custom prompt that you add, whatever it is, LLM will have those as well. So now you understand that LLM has so many functions and the prompt is also part of LLM. So that is why this block, the LLM block, becomes your brain of your voice AI operation. So that is exactly why we are picking the right model to run this brain. And you have so many providers such as OpenAI, Claude, Gemini, and so on, offering some LLM models. So depending on your use case, the cost associated, your preference, and so on, you will pick the right LLM model. So this is where all the various LLM models would fit into the bigger picture, right? And the output of an LLM is the same, text or words. So you get the same thing here as well. After processing the converted incoming speech, the LLM would generate a text output, which is sent out from LLM to the next module. And the next module would be the same like what you see here, but the only difference is that it is going to be the opposite of it. So if you take the whole thing here and you switch it out, and this will become TTS. Instead of STT, this will become TTS, which means text to speech. So this is the part where the words will get the voice. And in order to do that, you would use platforms like ElevenLabs, Cartesia, OpenAI, and so on. So this is the element where your text is getting a voice of its own. So you would need a voice provider for this part, and some of the popular ones are ElevenLabs, Cartesia, Rhyme AI, and so on. Depending on what is available to you, you can pick any one of these from the list. And then the output of this TTS would be voice again, and this will go back to the user and it completes one cycle. Again, you would need a telephony system here, such as Twilio or LC phone, for you to send out this voice to the user. So this is how voice AI works in the backend. So the user gives a call here, and when the user gives a call, voice reaches a system, and this voice will be converted into text by STT element, And the output of this STT element would be a text which goes into LLM. And this LLM model will process the incoming text through the prompt it has and also through the orchestration layer it has access to. And finally, it would create a text output which will be fed into a voice provider. And this voice provider will convert the incoming text into a voice through a platform like ElevenLabs. And the user receives a voice through the phone number they called in. And when they hear the voice and when they reply, it goes all the way back to STT again. And this cycle continues until the end of the conversation. So this is how a voice AI works in the backend. And this is a very simplified explanation just for you to understand the concept behind voice AI. So now that you understand the multiple elements involved in a voice AI, I'm going to show you how each of these individual elements is going to affect your voice call quality, latency, and such. So let's head over to a different platform now. So let's go to a platform called Vapi and understand how all of these would fit in. So now you are seeing a voice AI assistant inside Vapi, and you can pick and choose the model, the transcriber, and so on. So let's go ahead and see how that works here. So first thing that you need to select is the model, and you can see a list of providers here. There's OpenAI, there is Anthropic, there's Google, Grok, and so many other providers. You can pick whatever works for you, but for now, I'm gonna pick OpenAI. Then I can go into select a model that works for me. And when I go here, it will show me mainly two things. One is the latency and one is the cost. So latency is the time delay between the AI agent answering and you speaking. So if you have longer latency, you will wait longer for AI agent to understand you and to respond back. So sometimes if the latency is too long, you will feel that someone is not answering you, and that would lead to a bad user experience. So that is one reason why we always look for a lower latency in our voice AI calls. But sometimes latency is part of the game. So you need to find a sweet spot that works for you. All right. So here, if you look at GPT 5.2, it has a latency of 1,350 milliseconds. And if you look at GPT 5.2 instant, it has only a 700 millisecond latency, right? So if you have to pick between these two, maybe 5.2 instant is much faster, and you can pick that, right? And then you can also look at the cost that associated. But if you prefer a different model, you can scroll down and look at something like GPT-4o, which is very good for voice AI calls, because you can see why. GPT-4o cluster has only a 600 millisecond latency, and the cost is $0.02. Similarly, GPT-4o mini cluster is much faster and much cheaper. So you can go in and test out multiple models and how it works and how it behaves to the prompt that you have given. And once the model is giving you good enough results, you can pick that model, or you can try and adjust the model or try and adjust the prompt. So you have to understand that sometimes when you change the model, it would affect the way the voice AI agent would behave to the existing prompt. You may have the same prompt, but different models would behave differently to that same prompt. So you have to do a lot of trials before you pick your model, and you have to do a lot of trials when you're changing to a new model as well, even if you have the same prompt running. So this is how you would pick your provider and the model that works for your LLM. So that is the first part. And after that, we have to do the configuration of our voice. And like I said, there are multiple providers for voice as well. If you go in here, you can see Vapi, Cartesia, ElevenLabs, Rhyme AI, Deepgram. All of these providers would give you ample choice of voices. Again, you have to look into the latency and the cost associated with it. Vapi makes it so much easier. If you scroll all the way up, you will see a cost breakdown as well as the latency breakdown. As of now, the latency is about 1300 and the cost is about $0.11. And now I can go into the latency and look at each of the elements. And you can see here the latency is coming from transcriber. And if you scroll all the way down to find transcriber, this is what I was talking to you about. The STT, which is the speech to text conversion, and it is done by a transcriber. So you can find here Deepgram, ElevenLabs, Google, OpenAI, and so many providers. You can pick the provider that you like. Most of the time people pick Deepgram, which is popular and it is good. So you can select that. And then you can also pick the language from which you want this to be transcribed. So usually it's English. And as soon as you set the transcriber and you click publish, it will also show you the it will also show you the latency associated with the transcription. And if you look now, the transcriber latency for Deepgram is only 100 millisecond compared to what it was before. So if I go back and change it to another model, let's say Gladia, and if I publish this, and now if I go back and look at this, you can see that from 100 it has gone to 450 milliseconds. So that is why a lot of people choose Deepgram as their transcriber, because it is very efficient, very fast. And similarly, you can look into each of these elements and then you can decrease your latency. So here another 390 millisecond latency is coming from our model, which is pretty negligible. So that is good. So now if we go and change this out to Deepgram, we will have a shorter latency. So let's go change this to Deepgram and publish. And if you go back, the total latency is less than 1000 now. And now you can see that voice is taking about 400 milliseconds. So we can go back and change this to, let's say, Vapi and publish it. And you can see that the latency has come down to 250 now, and the total latency is about 840 milliseconds. So similarly, you can go in and pick and choose the model and things like that inside Vapi. But unfortunately, that's not the case with HighLevel. But this would give you an idea of how all these pieces that we were discussing earlier would fit into your voice AI and how it is affecting the total cost and how it is affecting the latency of your voice AI agent, right? And if you did miss that part of cost, we can go back here and look at the cost. And you can see here, hosting by Vapi is the major cost in here. And transcription is not that costly. Model is also cheap. And voice from Vapi is slightly on the higher side, but total cost comes around $0.09 per minute. So that is not too bad. And if you want to cut down the cost further, you could select a cheaper voice model. But the hosting cost associated with Vapi would be a fixed cost, so you don't have much choice in there. Anyway, this is how each of the model that you saw earlier would affect your total cost and latency. So I hope you have a better understanding of how voice AI works in the back end. And now let's go back and look at the LLM models that are available for us inside HighLevel. So here, let's go inside our models, and then you can see the cost associated with it. And if you want a cheaper model, you can pick 4o Mini, or you can scroll down and look at other providers as well. And there is Claude, there is Gemini, and you can also see the associated cost. And I will also have a video where I will go and test out all the models and see how they all perform. I will add the link to that video very soon. But for now, you can pick whatever works for you and you can run your own test and see if it is actually following the prompt as per your guidance. And you can also check if the voice AI is following all the guardrails that you have in place and it is not hallucinating and so on. Once you're happy with the model, the cost and the performance of the voice AI agent, you can finalize your model. But for now, I'm going to go with the recommended model, which is GPT-4o, which is really perfect to make any voice calls. So I hope you got a better understanding about LLM models and various components of voice AI. So now I will see you in the next lesson.